yeah, we're continuing. Sorry about that. It actually stopped. You're going to see a current slope like this. On this wire here, the 2nd amp clamp, it's hooked up to the common power supply. You have a power supply that goes into this harness and it splices at 1, 2, 3, 4 different points. So what that means is, as long as a coil fires, this amp will pick up 4 humps in 720 degrees of rotation. And this one will pick up only 1. Because of that, if you know the firing order of the engine, you can identify each peak and which cylinder that it's actually corresponded to. Okay, so we're going to demonstrate that by starting the engine. Can someone start the engine, please? Okay, as you can see in this video now, I'll try to do this and explain clearly. So, can someone just pause the recording, please? Excellent. So, as you can see at the bottom, that one singular trigger, that's the one that's attached to cylinder number 1 of the engine. Okay? So that means this one directly above it, okay? This peak right here, that's the current consumption of cylinder 1. We had to identify the cylinder firing order. And the firing order for this Hyundai engine is, what is it? 1, 4, 3, 2? Is it? Okay? 1, 4, 3. Let's just, for example, it's 1, 4, 3, 2. That means this hump represents cylinder 1, that one's cylinder 4, that one's cylinder 3, and that one's cylinder 2. Okay? Oops. And what this tells you is this engine obviously is running very, very smoothly. Okay? This graph is representing the current consumption by that ignition coil. Now, if you were to say have a misfire situation, 1342. Okay, sorry. Gevargis was able to look up on Protoman, which we should have done, and instead of me doing Mr. Guessy. 1342. So that's cylinder 1, cylinder 3, cylinder 4, cylinder 2. What we're going to do now is we're going to demonstrate a simulated misfire situation, okay? We're going to do a simulated misfire. Okay, engine's running. I'm going to do a simulated misfire, okay? So, or a dead cylinder. I'm just going to disconnect cylinder 4. Or actually, Gevargis, I gotta hold the camera. Do you mind disconnecting cylinder 4 for me? You have to squeeze the lock. Squeeze the end there, yeah. Okay, now the engine's misfiring. Now the reason why we gotta do this, there's many reasons why we do. So now let's look at this now. Mohammed, can you pause the recording again?
Yeah, sure.
Excellent. Check here. So we know the firing order was 1342, right?
Yes.
Cylinder 1 is still good. Cylinder 2 is still good. Oh, number 3 is missing. Number 4 is missing, and then number 2 is there. Yeah. You see that?
Yeah.
So this is a very quick way to check if a cylinder is completely dead. In this case, obviously, right? This would be a coil that's not firing at all because there's zero consumption. Okay. Now, in this case, you would check your power, check your control, check your voltage drops on both sides. It could be a bad coil entirely. But I want to also explain another situation. This is just an on and off situation. Okay. In a real world situation where, let's say, the power supply, maybe you have voltage drop on the power positive side, maybe you have resistance or corrosion, something that's causing, or even the windings inside, some of them are shorted. That current is basically voltage divided by resistance, right? But if your resistance has changed because the coil windings have shorted, your amperage is going to change if you have a bad coil. So you may have situations where it's not strictly just on and off. You might have a situation where you're going to have, for example, I'm just going to arbitrarily move my mouse and put it there, okay? You might have a peak that, let's say, is there. So you have 3 good ones, and you have one that's a little bit low. That means that coil, that circuit, is consuming low current. So in that case, you'd have to do your checks, your voltage drops and power supplies and all that, and then resolve it accordingly, okay?